The modern periodic table. They're talking about the system of classification, the different elements, those gas elements in the top. Moseley is a physicist. They're talking about different elements and revising the periodic table. The revised law is right there. And talking about when things repeat, how you can tell where they're going to be, organization of the periodic table, rows and columns, periods and columns. Final change is made. There are transition elements, representative elements. There are two forms of the periodic table used. There are old ones and new ones. There are atomic masses. On some periodic tables they talk about electrons, and helps you understand them. Here is the actual periodic table that they're talking about. First question. Periodic table was revised in the early 20th century because, flipping back, so the early 20th century, it was revised in the for a number. Every element fell into its proper group. So they were grouped by atomic number instead of atomic mass. So they were grouped. I'm going to say D for 31. So I'd say D. Number 32, according to this passage, which element is not a noble gas? Talked about gases where? Here? No. Here. Helium, neon, argon, xenon, and krypton. Helium, neon, argon, xenon, and krypton. Krypton doesn't say oxygen, so 32 is that. The atomic number of an element is determined by the atomic mass, right? Grouped by the atomic number instead of atomic mass. Nope. So the atomic number, property of the elements or periodic functions of the atomic number. The atomic number indicates the number of protons, also of electrons. So the atomic number is determined by number of protons and electrons. The main idea of 14 through 18. Let's go back to lines 14 through 18. When the elements were grouped by atomic number, every element fell in its proper group. So, the main idea of that is H. 35, what's the suggested connection between the revised periodic law and the revised periodic table? Revised periodic law states that elements are periodic functions of their numbers, and the revised periodic table sorts them according to their atomic number. So the revised table describes a law. Following the law, the table groups them by their number. Both use Roman numerals. The law is not a product of those. So the table describes the law, or groups them by their number. Does the revised table group them by their atomic number? Yes. So I'm going to go with B. Number 36. According to this passage, what's the connection between atomic number and atomic mass? According to the passage, what's the connection between atomic number and atomic mass? Atomic number is the number of protons and electrons. Atomic mass is how heavy it is. Shown beneath atomic numbers in the table. Atomic masses are shown beneath atomic numbers in the table. Okay? According to this passage, what's the connection between atomic number and atomic mass? They're always the same. No? Because otherwise atomic masses wouldn't be below atomic numbers. Looking at an atomic number there and atomic mass, they are not the same. Elements arranged in their atomic number are also arranged by atomic mass. That seems to be true. Element's atomic mass can change, but atomic number remains the same. Passage draws no clear connection between these two properties. I'm going to go with G. They met describes horizontal rows in revised periodic tables are periods. I read that. Passage suggests that A and B designations for elements are still reflected on the table, even though these designations have been replaced by representative elements and transition elements. Because so why does it use A's and B's even though they've been replaced? Since both forms are still used by chemists. It says up here, since both forms of the periodic table are commonly used by chemists, it gives the old ones and the new ones. So I'm going to go with F. Row of lanthanides. That's these ones down here at the bottom. And the row of actinides, which is the ones below it, are set apart because of what? There's that. They appear separately at the bottom. Placement makes it easier to follow the regularities following it. So they don't conform well to the other ones. Information is given about noble gases. That's not right. Carbon-12 standards. That's in there. Relative size or half-life. Relative size. Did I see something about relative size? Relative size, right there. Right there in that paragraph, which means I'm crossing off relative size, and my answer is half-life. Done. With 30 seconds to spare.